primary field of study is electrical engineering, and in particular it's electromagnetics. And this area covers different systems and devices that are based on the applications of electromagnetic field. And one of examples of this area is a radar system. And I guess every one of you may encounter a radar at least once in your life. Imagine you are driving a car in a highway, and to control your speed, a police officer standing on the roadside may want to have some tool to do it, and this tool is a radar. But generally, radars are used not only to track the violators of the speed regime, but also in other civil and military applications. But how exactly the radar works? What challenges you may face if you want to design a radar system, and in what application the radar can be used? This is what I will talk about in this presentation. The term radar was first introduced by US Navy, and it was an acronym for radio detection and ranging. So from this term itself, you can guess the main idea, that we can use radio waves to detect a target. And radio waves are electromagnetic waves, and basically they have the same nature as the visual light, but we just don't see them. And these waves can propagate in space or just to travel. And they carry electromagnetic energy, and when such a wave encounters an obstacle on its way, it can be reflected, refracted, or absorbed, depending on the properties of the surface of the structure. And in radar system, we mostly use the phenomenon of reflection. So let's have a look at the picture. In the bottom left corner, you see the main part of the whole story. That's an antenna. Antenna is used for transmitting and receiving electromagnetic waves. Imagine we want to track a target, such as the plane on the top right corner. The antenna sends an electromagnetic pulse. And pulse means that we shrink some amount of electromagnetic energy in some fixed, usually short, time interval. That pulse travels towards the target, reflects there, and goes back, and is captured by antenna. So by measuring the time interval needed for the pulse to go there and back again, and knowing its propagation velocity, we can calculate the path that was covered by that pulse. And that path is actually twice the distance from the antenna to the target. And in addition to the distance, we may also want to know if the target is moving or not, and if yes, then what's its velocity. In this case, antenna sends what we call a continuous wave signal. Continuous wave is just a sinusoidal signal with a certain frequency, and here frequency is just the main parameter that describes the signal. And the procedure is the same. We send the signal, take it back, and here something interesting happens. If the target is moving towards the antenna, the frequency of the received signal is higher than the frequency of the transmitted one. And in opposite, if the target was moving away from antenna, then the frequency is decreasing. So by measuring the frequency shift of the signals, we can calculate the velocity of the target. The physicists know this concept as a Doppler's effect, but we engineers just use it in our radar systems. And that sounds good, right? But in fact, it's not that easy, unfortunately. There are some factors that affect the electromagnetic wave propagation and that can change the signal. So the signal can be attenuated in the atmosphere, meaning that its intensity will be decreased. It can undergo some additional multiple reflections from the surface of the ground. It can be corrupted by some noise, for example, from other radars or any radio sources. And the higher is the noise, then the higher is the probability of missing the useful signal from the target or having a false alarm. So all these challenges have a lot of work, give a lot of work not only to the antenna engineer, but also to people who work in the field of digital communication or signal processing. And however, there are a great variety of radars that are used nowadays in different applications, such as air traffic control, fire control, surveillance, different tasks of moving target detections, and even missile seeking. And they are very different in the way how they look like. They have different size, different shape, but I hope I could explain you the basic principle of operation of the radar, and you can find something interesting here. So, thank you.